Hey guys, in this video we are going to be looking at fluid mechanics and the continuum. And this is the first thing that you learn when you're introduced to fluid mechanics, and it is very important because it essentially describes the gist of the theory for everything that you are about to learn. And so the challenge that we face when we are beginning to study fluid mechanics is that we have a Goldilocks dilemma. We need to draw control volumes that are not too big so that they aren't useful, and they're not too small so that they're not useful. We need to have something that's just right. And to hit home this dilemma that we face, we have, if we were to consider just 1 cubic inch of air, there are 10 to the 20th atoms of air inside this little control volume. And we will never have the technology to fully model 10 to the 20th atoms inside this little control volume. Even if we did fully understand the quantum mechanics behind it, it's just not possible. And so what we have to do is we have to turn to this concept called the continuum. And the continuum is, to use an example of density, because density is commonly a property that we care very much about with fluids. When we look at density, we know it's mass per volume, but the question is, how small do I make my control volume? Because the issue that we run into is that as I shrink my control volume, we leave the continuum domain and enter the molecular domain. And the molecular domain is where, as we're shrinking it down, we've got the electrons forming, a cloud around a nucleus. And so the density that we're calculating now in this fluid just begins to fluctuate so rapidly and violently that we can't really derive utility, and we can't accurately tell somebody what is the density of a fluid when we are analyzing control volumes that are just too small. Now, fortunately, there is something that we do have, which is this differential term, or del V. And so what this is, it's basically the smallest volume in which we have statistical averages that are meaningful. And what I mean by that are basically like we have a control volume that is sufficiently big so that we have enough atoms so that we can look at statistical averages of the group's behavior. And it's not too small so that we're now looking at individual particles and we have to worry about quantum mechanics, but it's not so big that we no longer have to worry about it. So like one of the things you learn in quantum mechanics, which is a completely different class, but it's basically as you have moles of something, you are able to now much more concretely define and predict the behavior of this bolus or control volume once you have 1 times 10 to the 23rd or thereabouts number of atoms or particles present. So this is what the continuum is. I'm going to keep this video short. I do think this was definitely one of the more interesting topics that I learned when I was getting introduced to this stuff. Hope this video helps. Let me know if you have any questions, and thank you all for watching.